Welcome back to the deep dive, where we cut through the noise and get straight to the knowledge you need. Okay, imagine this scenario for a second. You've got a nurse, right? Critically ill patient. She enters a medication order, but somewhere deep in the software, there's this glitch, and it miscalculates the dose. Or maybe worse, it sends the order to the wrong patient entirely.
It's a terrifying
Oh, it
thing.
really is. Or picture this. A big system update gets pushed out, and suddenly, bam, the entire patient records database crashes right in the middle of a busy hospital shift.
Yeah, these aren't just hypotheticals. These are the kinds of risks that healthcare organizations grapple with constantly.
Exactly. It sounds like a complete nightmare, but it's a very real, persistent risk.
Mm.
And the costs, well, they're astronomical. Way back in 2002, there was a study. It found software bugs alone were costing the U.S. economy nearly $60 billion annually.
Billion with a B. That's staggering.
It is. And, in healthcare, that error margin isn't just about dollars and cents. It's about lives. It's about patient safety. So today we're taking a deep dive into a really crucial area, system testing and evaluation in healthcare. Our mission here is to, well, pull back the curtain a bit on this really complex world of implementing and managing these information systems. Whether they're brand new or just modified, we're talking about hospitals, clinics, labs, really every corner of the healthcare universe. It's all about making sure these systems don't just, exist, but that they actually work flawlessly every single time. That's the goal, right?
Absolutely. And what's fascinating here, I think, is that this isn't just some technical detail left to the IT folks in the basement.
Right.
It is the absolute bedrock, the foundation for patient safety and, frankly, for the organization to even function efficiently. You have to think of these systems like the central nervous system of modern hospital or clinic.
That's a great analogy.
Yeah, they handle pretty much everything. Clinical data, obviously, patient care pathways, but also all the administrative stuff, the financial records, billing, scheduling, even really critical legal aspects of day-to-day operations. So if that central system malfunctions, if there's a bug lurking in there,
The ripple effect could be huge.
exactly, it's not just an inconvenience, like your email being down for an hour. It can directly impact patient outcomes. It can disrupt critical services, think emergency departments, operating rooms, and something maybe less tangible, but just as important, it can erode the fundamental trust that patients place in their care providers. If the systems don't work, how can they trust the care?
That trust issue is so critical, it really resonates. And our source material for today's deep dive, it's excerpts from 7 system testing and evaluation in healthcare. It really hammers this point home. It provides a really comprehensive look at the methodologies involved, but also just the sheer undeniable importance of getting this testing piece right from the very beginning.
It does. It lays it out quite clearly.
So let's unpack this a bit more. When we talk about system testing, specifically in the healthcare context, why is it such a monumental undertaking? What's at the core of it?
At its heart, it's all about managing risk. That's the fundamental purpose.
Okay, risk management.
Yeah. The goal of testing is to gather crucial knowledge about what a system can do, its capabilities, but maybe even more importantly, what it can't do, or where its limitations lie. You're actively trying to identify potential flaws, whether they're technical bugs or, ways the system doesn't quite match the operational workflow in the real world.
And finding them before they cause problems.
Precisely. Finding them and resolving them proactively before that system ever touches a real patient or a real clinical workflow. It's like proactive damage control for potentially catastrophic errors down the line.
That makes sense. And if we connect this, as you said, to the bigger picture in healthcare, those risks aren't just theoretical, are they?
Not at all.
Yeah.
In healthcare, those risks translate directly, sometimes immediately, into patient safety concerns. We're in an era now where information systems are just completely interwoven into almost every single aspect of patient care.
Everywhere you look.
Right. From the doctor ordering medication, to the pharmacy dispensing it accurately, to the nurse administering it. Think about diagnostic imaging. The system has to store and display the correct image for the correct patient. Think about coordinating care between different specialists or different departments. A malfunction, a glitch, a slowdown in any one of those areas can have immediate, potentially life-altering consequences for a patient.
Wow.
So this is why identifying and then rigorously testing for any potential patient safety risks that might be embedded within these complex systems, it's not just like good practice. It's really a moral imperative for healthcare providers.
A moral imperative. That puts a fine point on it. And you touched on the financial costs earlier, but let's revisit those numbers because they are just Mind-blowing.
They really are.
That National Institute of Standards and Technology study, NIST, back in 2002, $59.5 billion annually in the U.S. alone from software bugs.
Just incredible.
But here's the part that really got me. NIST found that over a third of those costs more than $20 billion back then could have been completely avoided.
Avoided how?
Through better testing. Specifically, testing that allowed for earlier and more effective identification and fixing of those defects before they got baked into the final product and deployed.
So catching them earlier saves massive amounts of money.
Exactly. And it gets worse. Fast forward to a 2017 estimate. The cumulative cost of software bugs and failures worldwide had ballooned to something like $1.7 trillion.
Trillion? Wow.
And affecting, they estimated, at least 3.7 billion people. So it's not just a drain on economies. It's a massive disruption to actual human lives and, in healthcare, potentially well-being.
It's an absolutely astronomical figure. And it really drives home the point about early detection, doesn't it?
This seems crucial.
It is. As our source material highlights, and it's a well-known principle in software development, the earlier a defect is found within that whole product development lifecycle, the cheaper and easier it is to fix, often exponentially so.
Can you give an analogy for that?
Sure. Think about building a house or maybe even a hospital wing. If you find a major structural flaw in the architect's blueprints, on paper,
Yeah.
fixing it might involve some redrawing, maybe some discussion. Relatively inexpensive. But if you only discover that same structural flaw after the concrete is poured, the walls are up, the roof is on, and you're about to install expensive medical equipment.
Oh, boy. The cost to fix it then would be enormous, ripping things out, rebuilding.
It's orders of magnitude more expensive and time-consuming. And in healthcare IT, that cost isn't just measured in dollars. It's measured in project delays, potentially delayed diagnoses for patients, inefficient care delivery because workarounds are needed, and in the worst-case scenarios, actual harm to patients because the system didn't perform as expected.
That blueprint analogy really clarifies it. Catch it early, fix it cheap. Catch it late, it costs a fortune, maybe more than just money.
Precisely. That's the core economic and safety argument for robust testing.
Okay, so the stakes are incredibly high, both financially and for patient safety. We need to test early and often. But what exactly are we putting under the microscope here? When we say system testing in healthcare, what does that encompass? Is it just about the software code?
That's a really good clarifying question. And no, it's definitely not just about the lines of code, although that's obviously a huge part of it. Our source material makes it clear that testing applies to both the hardware and the software components.
Ah, okay, hardware too.
Yep. Hardware testing involves evaluating the physical components. The circuits, the hard drives, the servers, the network gear, even peripherals like scanners or printers that interact with the system, making sure they're reliable, they meet specifications, they can handle the load.
Got it. Physical stuff.
Right. But then, of course, there's software testing. And that's where the deep investigation into the quality and functionality really happens. Software testing is all about validating that a software product does what it's supposed to do. And crucially, finding those hidden bugs or defects before that product gets released into the real high-stakes world of patient care.
Finding the gremlins in the machine.
Pretty much. Before they can cause any trouble.
So when we dig into the goals of software testing, what are we ultimately trying to achieve? Is it just, making sure buttons click and screens load? Or is it more profound?
Oh, it's much more profound than just checking buttons. So that's part of it, too. Ultimately, comprehensive software testing in a healthcare setting boils down to trying to achieve, I'd say, 3 core assurances.
Okay, what are they?
First, you need assurance that the system actually does what it's supposed to do. Does it meet all the design requirements? Does it meet the user requirements? Does it respond correctly and accurately to all the different kinds of inputs it might receive?
So functional correctness.
Exactly. Functional correctness is number 1. Second, you need assurance that the system does it reliably and performantly. Meaning, can it perform its functions efficiently? Does it respond within acceptable time frames, even when lots of people are using it simultaneously? Is it stable? Does it crash? Does it handle errors gracefully? Performance and reliability under real-world conditions.
Right. It can't just work. It has to work well, even under pressure.
Precisely. And third, and this is maybe the most critical in healthcare, you need assurance that the system is usable and safe for the actual people who will be relying on it day in and day out.
The doctors, nurses, administrators?
Yep. The end users. Is it intuitive enough? Does it fit their workflow? Can it be implemented and run smoothly in their specific hospital or clinic environment? Does it actually help them achieve the desired results? Better patient care, improved efficiency, whatever the goal was.
So function, performance, and usability safety.
Those are the pillars. And taken together, thorough testing provides that objective, independent view of the software. It gives healthcare leaders and clinicians a true understanding of the system's capabilities, its limitations, and crucially the risks involved before they commit to rolling it out widely.
It's about building confidence then, not just building a functional product. Confidence that it will work well, and be safe.
That's a perfect way to put it. Confidence is absolutely key when patient lives are potentially on the line.
Okay, so we've established the why, the massive risks, and the need for confidence. And we've clarified the what testing, both hardware and software, against function, performance, and usability goals. This brings us logically to the really practical question. How? How do hospitals and clinics actually conduct these tests? What's the process look like? Where do they even begin?
Right. The how is where the rubber meets the road. And the very first absolutely essential step, according to our source, is defining a test methodology.
A methodology. Okay, sounds formal. Why is that so crucial?
Well, it's the critical roadmap. Think of it as the overarching strategy and process guide for all testing activities related to that system. And it's especially crucial in healthcare because, as the source material points out, many healthcare organizations tend to buy, not build, their major IT solutions.
Ah, right. They purchase systems from vendors rather than developing them in-house.
Exactly. They might buy a big electronic health record system, or a scheduling system, or a billing system from a specialized vendor. Sometimes they might outsource development for specific modules. This means their own internal IT staff often has only a partial understanding of the system's deep internal workings or its complex development history. They didn't write the code line by line.
So the methodology bridges that knowledge gap.
In a way, yes. A well-defined methodology ensures that even if your team didn't build it from scratch, you have a structured, repeatable process to verify that the product works according to its specifications, that it doesn't have unintended negative side effects, and critically, that if it does encounter an unexpected problem, it fails safely or gracefully rather than catastrophically.
Okay, so it provides structure and safety, especially with external products. What does a good methodology typically include? What are the key steps?
A sound testing methodology generally covers several key phases. First, you define the overall test strategy. We can talk more about that. Then you develop the necessary test tools and environment. After that comes the actual execution of the testing. While testing, you need to employ test controls, things like version control and security. Then, ongoing reporting of results is vital. And finally, you perform a comprehensive final evaluation.
Strategy, tools, execution controls, reporting, evaluation. Got it. It sounds quite comprehensive.
It needs to be, given the complexity and the stakes involved.
Okay, let's dive into that first step you mentioned, the test strategy. You called it the high-level game plan. What exactly goes into that? Is it like a detailed script or more of a framework?
It's definitely more of a framework, a high-level plan. It outlines how the system is going to be tested to make sure all the objectives we talked about, function, performance, usability, are actually met.
So what kind of things would you find in a test strategy document?
It's usually quite comprehensive. It covers the scope of the testing, what parts of the system are in scope, what's out of scope, the specific objectives of the testing effort, the roles and responsibilities, who is doing what, who owns which part of the process.
Okay.
It also details reporting methods. How will status be communicated? To whom and how often? Will test automation be used? And if so, how and for what? What are the expected deliverables from the testing process, test plans, reports, etc.? Are there specific industry standards or regulations that need to be adhered to during testing?
Like IPF, for example.
Exactly. IPA compliance testing would definitely be part of the strategy for many healthcare systems. Then what metrics will be tracked to measure progress and success? Things like defect density, test coverage, pass-fail rates. How will risks associated with testing itself be identified and mitigated? How will defects be formally reported, tracked, prioritized, and resolved? And, very importantly, how will changes to the system or the requirements during the testing phase be managed? That's change control.
Wow, that's a lot more than I might have guessed. It really sets the stage for everything that follows.
It does. And this test strategy is usually the precursor to a more detailed test plan. The plan gets into the real nitty-gritty.
How does the test plan differ from the strategy?
If the strategy is the what and how at a high level, the test plan is the detailed execution guide. It's often derived directly from the business and user requirements for the system. It contains things like specific test cases, detailed steps to perform a particular test, the test conditions or scenarios being tested, detailed schedules for testing activities, specifications for the test environments needed, and crucially, the explicit pass-fail criteria for each test case or component.
So the plan is where you find the step-by-step instructions.
Pretty much. And it's a foundational document. It should be reviewed and agreed upon by all the key stakeholders, the business users, the IT team, the vendor, if applicable, before the actual testing kicks off. This really helps reduce ambiguity and ensures everyone is aligned on what success looks like.
That alignment seems absolutely critical. Okay, so we have the methodology, the strategy, the detailed plan. Now we get to the actual doing of the tests. Our source mentions two main categories of test tools or approaches, manual and automated. Can you break those down?
Sure. Let's start with manual testing. This is, well, exactly what it sounds like. It involves direct human interaction with the system under test.
So a person sitting at the computer clicking through screens.
Essentially, yes. A tester, often playing the role of an end user like a nurse or a doctor, follows a predefined test plan or script. They execute the steps, observe the system's behavior, compare the actual results to the expected results documented in the plan, and log any discrepancies as defects.
What are the pros and cons of doing it manually?
Well, the big pro is that a human tester can bring intuition, experience, and exploratory skills to the table. They might notice usability issues or inconsistencies that weren't explicitly scripted. They can assess the feel of the system.
Okay, the human touch.
Right. But the cons are significant too. Manual testing is very labor-intensive. It takes a lot of human hours, which translates to cost. It's also time-consuming, especially for large, complex systems with thousands of test cases. And, frankly, it can be prone to human error. Testers might miss steps, make mistakes in recording results, or just get fatigued doing repetitive tasks. Plus, it's hard to perfectly replicate the exact same test conditions every single time manually.
I can see that. Doing the same clicks over and over. Tedious and error-prone.
Exactly. And that's where automated testing comes into the picture.
Using software to test software.
Precisely. Automated testing uses specialized software tools separate from the application being tested to control the execution of tests. These tools can automatically run predefined test scripts, interact with the system's user interface or underlying code, APIs, compare the actual outcomes against the expected outcomes, set up necessary preconditions for tests, and automatically generate detailed reports.
That sounds much more efficient.
It can be, significantly. Our source notes that the use of automated testing tools is definitely expanding rapidly in healthcare, and for very good reasons.
What are the biggest benefits?
Speed and repeatability are huge. Once you've written an automated test script, the tool can execute it much, much faster than a human could. And it can run that same test over and over again exactly the same way, thousands of times if needed, without getting tired or making errors.
I see. So for things that need to be checked repeatedly.
It's incredibly valuable. Think about regression testing, which we'll discuss later. Every time there's a small change, a patch, or an upgrade to the system, you need to rerun a whole suite of tests to make sure nothing broke. Doing that manually every time would be incredibly slow and expensive. Automation makes it feasible and cost-effective.
That makes a lot of sense, especially for systems that, as the source says, have a long maintenance life with frequent updates, which sounds exactly like most major healthcare IT systems.
It is. EHRs, billing systems, they get patched and upgraded constantly.
Right.
Automation is really key to managing the testing workload for those ongoing changes effectively. It significantly improves the efficiency and reliability of the testing process.
Okay, the efficiency gains are clear. But, this raises an important question for me. Thinking back to the human touch you mentioned for manual testing, how do organizations balance the raw speed and efficiency of automated testing with those more nuanced, perhaps intuitive insights that a human tester might bring? Especially when you're testing complex clinical workflows that involve, real patient interaction or difficult judgment calls. Is there a risk of relying too much on automation?
That's a really critical point, and it's something healthcare organizations definitely need to consider carefully. You've hit on a key insight. While automation is fantastic for repetitive, predictable tasks like checking data validation rules, verifying calculations, running load tests, confirming basic functions work after a patch work, it often struggles with replicating the nuances of complex human judgment and interaction.
How so?
Well, an automated script can follow predefined steps perfectly,
Yeah.
but it can't easily assess the usability of a new screen layout in a high-pressure emergency room setting. It can't really evaluate if a particular clinical workflow feels intuitive or cumbersome to a busy clinician. It might not anticipate the unexpected ways a stressed user might try to interact with the system, ways that weren't captured in the requirements.
So it might miss things a human would catch just by using it in context.
Exactly. A human tester, especially one with clinical experience, can bring that domain knowledge. They can perform exploratory testing, going off script to see what happens. They can provide subjective feedback on the user experience, the feel of the system, which is incredibly important for user adoption in healthcare. Automation simply cannot replicate that human-in-the-loop element effectively for all types of testing.
So it's not an either situation then, manual versus automated.
Generally, no. The most effective approach, especially in complex domains like healthcare, is often a hybrid one. You leverage automation for its strength. Speed, repeatability, broad coverage of routine checks, regression testing, performance testing. But you combine that with targeted manual testing, often involving actual end users or testers with clinical backgrounds, to focus on usability, complex workflows, exploratory testing, and acceptance testing scenarios that require that human judgment and perspective.
Finding that sweet spot, using the right tool for the right job.
Precisely. It's about strategically blending the efficiency of automation with the essential insights that only human testers can provide. That's how you get the most comprehensive and confidence-building test results.
That makes a lot of sense. Okay, so we've covered the how in terms of methodology, strategy, planning, and the tools manual and automated, and ideally a blend. Now let's get even more specific about the different types of test execution. Our source material categorizes these in a couple of useful ways. First, it talks about different box testing approaches, which seem to relate to the tester's viewpoint or level of knowledge about the system's internals.
That's right. It's a common way to classify testing based on how much the tester knows about what's going on inside the system.
So what are the boxes?
Well, first you have white box testing. Think of a transparent box where you can see all the inner workings.
Okay, seeing inside.
Exactly. In white box testing, the tester has detailed knowledge of the system's internal structure, design, and code. They're looking at the code itself, the database structures, the specific pathways that data takes through the software. The goal is to verify the internal logic, ensure all code branches are tested, check for potential security vulnerabilities in the code, and optimize performance based on understanding the internal algorithms.
So this is typically done by developers or someone who can read code.
Yes, often programmers or specialized white box testers perform this. They need that deep technical understanding.
Got it. What's the opposite then?
The opposite is black box testing. Here, you treat the system like an opaque box. You know what it's supposed to do based on requirements, but you have no knowledge of how it does it internally.
Like a user would experience it.
Exactly. The tester focuses purely on the inputs and outputs. They provide inputs like clicking buttons, entering data, observe the outputs, what appears on the screen, what data is generated, and verify if the system behaves according to its specifications and requirements without any concern for the internal code structure.
This sounds like functional testing.
It is. Black box testing is often synonymous with functional testing. It's focused on validating the system's functionality from an external perspective.
Okay, white internal and black external. Is there anything in between?
Yes, there is. And it's called, perhaps predictably, gray box testing.
A mix of both.
Right. In gray box testing, the tester has some knowledge of the internal workings. Maybe they understand the database schema, or they know about key algorithms, or they have access to design documents, but they don't necessarily need to examine the code line by line like in white box testing. They use this limited internal knowledge to design more effective black box tests, or to better understand the root cause of failures observed from the outside.
When would gray box be particularly useful?
Our source suggests it's often very useful for testing integration points between different system modules, or when testing upgraded or modified existing systems. You might know how the old system worked internally, which helps you test the changes more effectively. It combines the external focus of black box with some internal insight.
White, black, gray. That clarifies the viewpoints. Now, our source also classifies test methods in another way, by their level within the overall development process or by their specific objective. Can you walk us through some of the key types here, maybe highlighting the ones that are especially critical in healthcare?
Absolutely. This classification helps us understand when and why different types of testing are performed during the system lifecycle. So starting at the lowest level, very early in development, we have unit testing.
Unit, meaning small parts.
Exactly. A unit is the smallest testable piece of an application, typically an individual function, method, procedure, or maybe a small class or module of code. Unit testing is usually done by the programmers themselves as they write the code. They write small test scripts to verify that each individual unit works correctly in isolation, that it handles expected inputs, rejects bad inputs, and produces the right output. It's often considered a white box technique.
So catching errors right at the source in the individual building blocks.
Precisely. It's fundamental for building quality in from the start. Then, once the individual units seem to be working, you move up a level to integration testing.
Putting the units together.
You got it. Integration testing involves combining those individual software modules or units and testing them as a group. The focus here is on verifying the interactions and interfaces between the units. Do they pass data correctly? Do they call each other properly? Do the combined pieces work together seamlessly?
Okay, checking the connections. What kind of box testing is this usually?
Integration testing often lends itself well to gray box testing because you might need some knowledge of how the modules are supposed to connect internally, but you're primarily testing their combined external behavior.
Unit, then integration. What comes next?
Next, you typically move to system testing. Now you're looking at the entire integrated system as a whole.
The complete application.
Yes, or a major subsystem. System testing is conducted on a complete, integrated system to evaluate its compliance with the overall specified requirements, both functional and non-functional, like performance reliability. It often involves testing the system's interaction with its intended hardware, operating system, and maybe other external applications it needs to communicate with. This is very often conducted using black box methods, focusing on the end-to-end behavior from the user's perspective.
This sounds like a really critical phase, making sure the whole orchestra plays together correctly.
It absolutely is. This is where you really start to see if all the pieces built and integrated actually deliver the intended overall functionality and quality.
Okay, so unit integration, system testing seem like levels building on each other. You also mentioned tests classified by objective. What are some key examples there?
Right. These types of tests focus on verifying specific quality attributes or achieving particular goals, rather than just being a level in the process. A really important one is stress testing.
Stress testing. Sounds intense. Pushing it hard.
Exactly. Stress testing deliberately pushes the system beyond its normal expected operational capacity, sometimes even to a breaking point.
Why would you want to break it?
The goal isn't just to see if it breaks, but how it breaks and how it recovers. Stress testing focuses on determining the system's robustness, availability, and error handling capabilities under extremely heavy load or adverse conditions. You might simulate a huge number of concurrent users, flooded with massive amounts of data, or deliberately starve it of resources like memory or network bandwidth.
I can see how that would be vital in healthcare. You mentioned earlier like a mass casualty event scenario.
Precisely. Imagine a large hospital's EHR system during a major emergency. Suddenly, hundreds, maybe thousands of doctors, nurses, lab techs are all trying to access patient charts, enter orders, view results simultaneously. Stress testing helps answer. Can the system handle that peak load? Does it slow down to a crawl? Does it crash? If it does crash, does it corrupt data? How quickly can it recover? Understanding these limits before a real crisis is crucial.
Absolutely critical. What other objective-based tests are important?
Another major one, often considered the final gateway before deployment, is acceptance testing, which is frequently referred to as user acceptance testing, or UAT.
UAT, I've heard that term. Who does this?
This testing is conducted specifically to determine if the system meets the requirements outlined in a contract or a business requirement specification. And critically, it's typically performed by the actual business customers or end users, the people who will ultimately use the system in their daily work.
So the nurses, doctors, billing clerks, administrators get their hands on it.
Yes, they run realistic scenarios, often using real but anonymized data in a dedicated test environment to confirm that the system meets their needs, supports their workflows, and delivers the expected business value.
Why is this considered such a final gateway?
Because it's essentially the sign-off from the people who requested the system. It's their chance to say, yes, this meets our needs, we accept it. Or, no, this isn't quite right yet, these issues need to be fixed before we go live. Our source implicitly argues, and I think it's right, that while all the previous testing phases are technically vital, UAT is often the true litmus test in healthcare. It directly verifies if the system aligns with the lived realities and complex workflows of those frontline clinicians and staff. Their buy-in and acceptance based on successful UAT is absolutely paramount for the system to be adopted successfully and used effectively. If they don't accept it, the project can falter badly, regardless of how well it performed in earlier tests.
That makes perfect sense. If the people who have to use it every single day aren't happy with it or don't feel it meets their needs, then all the technical testing in the world might not translate to real-world success.
Exactly. UAT is that crucial bridge between technical validation and real-world operational readiness and acceptance.
Okay, stress testing, acceptance testing. Any other major types we should cover?
One more that's incredibly important, especially for ongoing maintenance, is regression testing.
Regression, like going backwards.
Sort of. Regression testing isn't about testing new features. It's about making sure that changes made to the system haven't negatively impacted existing functionality or reintroduced old bugs that were previously fixed.
Ah, so you make a change and then you test to make sure you didn't break something else unintentionally.
Precisely. It can be any type of testing unit, integration, system, even acceptance tests that is specifically performed to uncover new defects or regressions in the existing functional parts of the system after some kind of change has occurred. That change could be a bug fix, a software patch, a performance enhancement, a configuration update, anything.
Why is this so critical?
Because software systems, especially large healthcare systems, are incredibly complex and interconnected. A seemingly small change in one module can have unforeseen ripple effects, inadvertently breaking functionality in a completely different part of the system.
The law of unintended consequences.
You got it. Regression testing is the safety net that helps catch those unintended consequences. It typically involves rerunning a subset, or sometimes all, of the tests that were previously passed to ensure that the expected behavior is still occurring and that previously fixed bugs haven't mysteriously reappeared.
And given how often healthcare systems are updated,
Regression testing becomes a constant essential activity throughout the entire life cycle of the system, not just during initial development. It's absolutely critical for maintaining stability and reliability in a production environment.
okay, so we have these levels, unit, integration, system, and these objective-focused types like stress, acceptance, and regression. It seems like they all play distinct but complementary roles.
They do. They build upon each other. Unit tests ensure the bricks are solid. Integration tests ensure the bricks fit together. System tests ensure the whole wall stands up. And then objective tests like stress and acceptance testing ensure the wall can withstand weather and is fit for purpose, while regression testing ensures repairs don't weaken the structure elsewhere. It's a layered approach to building confidence.
That's a great way to visualize it. All these layers of testing. Now, with all this testing happening, potentially involving different teams, different environments, maybe even vendor involvement, how do you keep it all organized and secure? How do you make sure the testing process itself doesn't introduce new risks, especially around sensitive patient data?
That's a crucial consideration. The testing process itself needs controls. Our source introduces this idea of test controls. These are specific measures put in place to protect data confidentiality, integrity, and availability during the design, development, testing, and eventual deployment phases. They're like the guardrails for the entire testing ecosystem.
Guardrails, I like that. What are some common types of these test controls?
Our source highlights three particularly common and important ones. The first is version control, which you might also hear called revision control or source control.
Like tracking changes to documents or code?
Exactly. Version control systems track and manage changes made to source code, scripts, configuration files, even requirement documents and test plans over time.
Why is that a control in the testing context?
It's vital for several reasons. First, multiple versions of software often exist simultaneously. The current production version, the version being tested, maybe older versions still supported. Version control allows you to know exactly which version of the code or component a specific bug was found in. This is crucial for accurately reporting the bug and ensuring the developers fix it in the correct code base. It also allows you to reliably revert to a previous known good version if a new change causes major problems. And it helps manage collaboration when multiple testers or developers are working on the same system components. It provides an audit trail of who changed what, when, and why.
Okay, so traceability and stability through tracking changes. That makes sense. What's the second control?
The second one is security audits. These are systematic, often measurable, technical assessments of a system's or application's security posture.
So checking for vulnerabilities.
Yes, but it could be broader than just vulnerability scanning. Security audits can involve various methods that might include interviewing staff about security procedures, manually reviewing access control lists and permissions, performing vulnerability scans on the network or application, penetration testing, trying to ethically hack the system, reviewing system logs for suspicious activity, or using automated tools that monitor configurations and generate audit reports against security benchmarks.
And this happens during testing, not just before go live.
Ideally, Security considerations and audits should be integrated throughout the entire life cycle, including the testing phases. You want to ensure the test environments themselves are secure, especially if they contain sensitive, even if anonymized data. You also want to test the security features of the application itself before it goes live. These audits aren't just technical checks. They are absolutely fundamental in healthcare for understanding and mitigating vulnerabilities that could lead to devastating data breaches, ransomware attacks, or system compromises that put patient safety at risk.
So version control for managing changes, security audits for finding weaknesses. What's the third key control?
The third one is change control, sometimes called change management. This is a more formal, procedural control.
How does that differ from version control?
While version control tracks the technical changes, change control manages the process by which changes are proposed, reviewed, approved, implemented, and verified. It's a formal workflow. The goal is to ensure that any modification to a system, whether it's applying a software patch, updating a configuration setting, changing network rules, upgrading hardware, or even rolling out a major new version, is introduced in a controlled, coordinated, and authorized manner.
Why the formality?
It helps reduce the risk of chaos. In complex healthcare environments, multiple teams might be working on interconnected systems. Without a formal change control process, one team might make a change that inadvertently breaks something for another team. Or unnecessary changes might be made without proper testing or consideration of the impact. Or multiple conflicting changes might be attempted simultaneously.
I can see how that could quickly lead to instability.
Absolutely. A good change control process involves documenting the proposed change, assessing its potential impact and risk, getting approval from relevant stakeholders, including business owners, IT, security, scheduling the change appropriately, often during maintenance windows, communicating the change to affected parties, having a backup plan if things go wrong, and verifying the change was successful after implementation.
It sounds bureaucratic, but necessary.
It can feel that way sometimes, but it's absolutely vital for maintaining the stability, security, and reliability of critical healthcare systems. These controls, version control, security audits, change control, aren't just technical nice-to-haves. They are critical management disciplines for governing the entire testing environment and the transition of systems into production, especially within those complex, interconnected healthcare networks. They enforce accountability and help prevent costly, potentially dangerous unintended consequences.
Guardrails is definitely the right word for them. Okay, so we've planned, we've tested using various methods, we've controlled the process. Eventually, all this activity generates results, information. How does that get communicated? Let's talk about test results reporting.
Right, reporting is key because testing isn't done in a vacuum. Various stakeholders need to know what's going on.
And our source emphasizes something important here. Reporting isn't just a final step, is it? It happens throughout the testing process.
That's a critical point. You don't just wait until the very end and dump a massive report on someone's desk. Stakeholders, project managers, business owners, developers, maybe even executives often expect and need frequent updates on how the testing is progressing.
How frequent is frequent?
It varies, but sometimes it can be daily, especially during critical test phases like UAT or just before a go-live. They need regular status updates on testing activities performed, tests passed, tests failed, defects found, critical issues blocking progress, and adherence to the schedule.
What are some of the challenges in doing this reporting effectively?
Well, our source points out a few common ones. First, tailoring the report to the audience. The level of technical detail a developer needs is very different from what an executive sponsor wants to see. So you often need different report formats or summaries for different stakeholders.
Makes sense. One size doesn't fit all.
Exactly. Second, clearly clarifying the intent of the specific testing being reported on. Was it functional testing, performance, security? The context matters. Third, briefly explaining the methodology used so the audience understands how the results were obtained. And fourth, a big one, is identifying meaningful metrics. Just reporting 1,000 test run isn't very useful. Metrics like defect density, test coverage percentage, defect severity distribution, pass-fail trends over time, these provide much more insight into the quality of the system and the effectiveness of the testing.
So, making the data tell a story, what should be in a good test report, at a minimum?
At a minimum, our source suggests reports should cover the overall mission or objective of the testing covered by the report, the specific systems or modules tested, an assessment of the organizational risk based on the findings so far, the techniques and tools used, the test environment description, the current status, pass-fail counts, defects, and any obstacles or critical issues encountered.
That ongoing communication seems vital for keeping everyone informed and managing expectations.
Absolutely. Transparency is key.
And all that ongoing reporting eventually builds towards the grand finale, right? The final evaluation.
Yes. This is arguably the single most important deliverable to come out of the entire system testing effort,
Why is it so crucial?
because it synthesizes all the findings from the various test phases and provides a comprehensive assessment of the system's readiness. It contains the detailed findings, the overall conclusions, and actionable recommendations for the stakeholders.
What kind of conclusions and recommendations?
Well, for tests that were largely successful, the final evaluation confirms for stakeholders that the system has indeed achieved the expected results.
Yeah.
And crucially, it often tries to quantify or describe how those test results are likely to impact the anticipated business outcomes or benefits that justified the project in the first place.
Like the ROI.
Exactly. For example, if a new billing system was supposed to increase insurance collections, the evaluation might include findings from testing that support or refute that claim based on simulated data. Or if a new clinical decision support feature was meant to reduce medication errors, the evaluation might present test results showing its effectiveness in catching potential errors. Connecting the testing back to the business case makes the value clear,
So, it justifies the investment.
hopefully. But it's also about answering those key questions stakeholders have right before deployment. Does the system truly meet the required quality and performance standards? Is it really ready for end users? What kind of performance and stability can we realistically expect under heavy production load? And bottom line, what is the overall risk associated with going live now?
That go-no-go decision often hinges on this evaluation, I imagine.
Very much so. The final evaluation provides the critical data and analysis needed to make an informed go-live decision. It might also highlight specific areas where, say, additional end-user training is needed before deployment, based on usability issues found during testing.
And you mentioned continuous improvement earlier.
Yes. A really critical insight here is that the final evaluation shouldn't just be filed away. It should always include a section on lessons learned. What went well during the testing process? What challenges were encountered? How could the test strategy, tools, or processes be improved for the next project or the next round of testing on this system? Capturing and acting on those lessons learned fosters that vital culture of continuous improvement in testing practices.
So the evaluation looks back to learn, looks at the present to decide on go live, and looks forward to potential impacts and future improvements.
That's a great summary of its role.
And the evaluation doesn't stop at go live, does it? Our source mentions post-implementation evaluations.
That's right. The journey isn't over once the system is switched on. Savvy organizations conduct post-implementation evaluations, maybe a few weeks or months after go-live, to measure how things are actually going in the real world.
What do they measure then?
Things like initial and potentially long-term user satisfaction. Are the clinicians actually happy with it? System usability in the production environment. The actual observed impact on business processes and patient care. Did we achieve those ROI goals? Are there unexpected problems or benefits? And they also assess the system's potential for future expansion, modification, or integration with other systems based on the initial real-world experience.
It really is a continuous life cycle then. Test, evaluate, deploy, evaluate again, learn, improve.
Exactly,
Yeah.
especially with complex, long-lived healthcare systems.
So after diving deep into all of this, the why, the what, the how, the controls, the reporting, what does this all mean? What's the big picture for you, the listener, whether you work in healthcare IT or you're a clinician using these systems, or frankly, just someone who relies on the healthcare system for your own care?
Yeah, what's the key takeaway?
Well, I think it boils down to this. Truly thorough, well-planned system testing and evaluation is, quite simply, the most successful and the most ethical way we have to manage and mitigate the inherent risks involved in deploying new or modified healthcare information systems. We've seen it's a complex process, no doubt about it. It can be time-consuming. It requires significant resources and expertise, especially given those intricate clinical workflows and the vast interconnected networks we see in healthcare today.
It's not trivial.
Not at all. But it is, without question, absolutely essential. It's essential for ensuring these critical systems perform consistently, reliably, and safely. And ultimately, it's essential for supporting the delivery of high-quality, efficient, and fundamentally trustworthy patient care. You can't have safe care without reliable systems underpinning it.
Well said. And perhaps a final thought to leave people with. Something to mull over. Given how incredibly rapidly healthcare technology continues to evolve, AI, interoperability, cloud migrations, cybersecurity threats, and how deeply interconnected all these systems are becoming. The really interesting question for organizations is, how do you ensure that your testing strategies and practices remain agile and adaptive enough? How do you keep pace? How do you ensure you can effectively test for emerging threats and leverage new opportunities long after that initial go-live date has passed? It really emphasizes that testing and evaluation isn't a one-time project with an end date. It has to be a continuous evolving journey of vigilance, adaptation, and improvement to keep pace with the technology and the changing healthcare landscape.
That's a truly powerful thought. Vigilance and adaptation. It's not just about testing the system you have today, but being ready to test the system you'll need tomorrow. A reminder that our digital health infrastructure is almost like a living, breathing entity that requires constant care and attention. We really hope this deep dive into system testing and evaluation in healthcare has given you a much clearer picture of the immense effort, planning, and rigor that goes into keeping these critical systems robust, reliable, and safe. Thank you so much for joining us on the deep dive today. We encourage you, as always, to keep exploring how technology is shaping and hopefully improving your world.